Well, my name is Sean Johnson. Today I'm going to share some research I did with Professor John Bells over the summer, in which we replicated a seminal paper by Matthew Choptuik about critical phenomena and gravitational collapse. I'd also like to thank the University of Utah Graduate Physics Program and the Swigart Endowment for the funding over the summer. So in this presentation, I'm going to go over the type of research that we do and how it helps progress the understanding about the theory of gravity and an interesting thing that came up about naked singularities and its implications for the cosmic censorship hypothesis. So first of all, the type of research we do is numerical relativity, in which we take model data in the beginning and use computers to progress it and solve Einstein's equations. This is due to the high level of difficulty to solve Einstein's equations. There are 10 nonlinear partial differential equations, and to this day, there are only a few known analytical solutions. As you progress and get these solutions, we can further understand theory of gravity and create more analytical approximations to solve without using computers in the future. So in particular, what we did over the summer was critical collapse, which is black hole collapse. We would take different initial profiles that could be Gaussian, Poissonian, or different profiles, and we would only alter one of the parameters, for example, just the amplitude. And we would find a critical parameter, which, for an example, an amplitude above this critical parameter would collapse into a black hole, and below it, the field would simply just disperse. So the three critical phenomena that were viewed was, first of all, universality, which is regardless of the initial profile of the model data, as it approached the critical point, it would have this same shape and development of the field. The other is echoing, which is shown in the top right, that the field actually repeats the same shape as it progresses towards the critical parameter. There are three colors shown. Blue is the earliest profile, orange is the later profile, and green is the latest of them. As you can see, they repeat the same shape, and they do it out to a not specifically defined radius out from the origin. As can be seen, the x-axis is the origin and the y-axis is the field. Sorry, x-axis is distance from the origin. And the third thing we viewed was power law, which is the distance of the parameter away from the critical parameter is proportional to the black hole mass that is formed. So this means as we get closer to the critical parameter, our black hole mass gets smaller and smaller and smaller, and it can actually lead to infinitesimal mass black holes, which wouldn't have an event horizon, which leads to a naked singularity. This is actually against the cosmic censorship hypothesis, which predicts that a naked singularity is not possible. But actually, a fun fact, due to this initial paper by Matthew Choptuik, Stephen Hawking lost a bet that it was impossible to create a naked singularity with physical initial data. And as you can see, Matthew Choptuik was able to do it. He then changed his definition of what would count as a naked singularity and re-signed a new bet with the same professors. So in summary, black hole collapse shows critical phenomena such as echoing, universality, and the power law. And this leads to further questions about naked singularities and can lead to steps towards unification of gravity theory with quantum theory. Thank you for your time.